Homework 18, section 8.3, confidence intervals for population proportions, video 5. In the last video, we had a formula for controlling the margin of error. I meant to write it on the board prior to starting this video, but it won't take but just a second to write it. You square the z on top, you multiply it times p hat, you multiply that times 1 minus p hat. And on the bottom, you square the margin of error. That just doesn't look good to me. It's better. But the circular dilemma here, the catch-22 is if we're determining the right sample size to pick, then we haven't picked a sample yet. And if we haven't picked a sample yet, we don't have the p hat value. And if we don't have the p hat value, we can't calculate the size of the sample we need to pick. It's like, oh no, what do? Well, I'll tell you what to do. If you're controlling the margin of error, but you have no previous p hat value, for example, what if we didn't have the p hat value in the previous problem? Can we keep the margin of error less than or equal to 2% with a 99.5% confidence level? And the answer is yes. In the last video I said, I'll show you the algebra if you ask me. I think I'm actually going to show you. Don't worry, it won't hurt, and I won't ask you to repeat it. But if we don't know the value of p hat, then the question is how large or how small can this thing get? And I kind of already told you, but I want to give you the reason why. If you were to change this p hat to an x just for a second and call it a function, f of x equals. Now we could say f of p hat equals, but for those of you who had algebra before, and you've all had high school algebra, so you have, then calling this x makes it look more like something you've seen before. F of x equals x times 1 minus x. So just change the value p hat to x generically for a moment. If you were to distribute this and rearrange the terms, you would get negative x squared plus x. So, well, you may know that this is a parabola and it's upside down. And you might know that it crosses the x-axis at 0 and 1. So if we're controlling the margin of error, we want to know how big can this expression get? Well, based on the symmetry of a parabola, the highest point on this parabola occurs dead center between 0 and 1. And what number is dead center between 0 and 1? 0.5. So 0.5 would give us the maximum value of this, which would tell us how big our sample size would need to be. The minimum value is 0. If this is 1 or if this is 0, the whole thing becomes 0. That would give us the smallest sample size. Oh, when your sample size is 0, that didn't even make sense. So what I'm about to show you is the algebraic effort to control how large this product gets. And the largest it gets happens when p hat is exactly 0.5. So what does that mean over here? In the absence of a p hat value, comma, use p hat equals 0.5 to get the largest possible n. So you just use p hat equals 0.5. Now if you happen to be looking in the textbook and you look at this formula on the bottom of page 392, it will tell you to just put 0.25 for that whole circle product, which is the same as putting in 0.5. So I'm just going to say, if you don't have a p hat, use 50%. So there's a short version of it. If there's no p hat value, just use 50%. In some books, this is called the most conservative estimate because it maximizes the value that we need. But I digress. If you don't have a p hat, put in 0.5. So we would have n equals, our z was still 2.81, so it gets squared. If we don't have a p hat, we use 0.5, so times 0.5 times 1 minus 0.5, which is also 0.5, divided by the square of the largest margin of error we want to obtain, which is 2%. So all that would go into a calculator, and then something would come out. All right, so give me a second to multiply this. I get exactly, no rounding, 4,935.0625. And so we always round up. So we would round it up to 4,936. That's the largest sample size, that's the smallest sample size we would need to keep the margin of error under control. I don't recall what the previous value was in the previous video. I'm pretty sure it was smaller than that. Give me 1 second, I'm about to find out. 638. No, 638. 638. Yeah, in the previous example, I believe it was 4,560. That doesn't sound right, but it was less than this. So this is the smallest sample size under any circumstances that would guarantee a margin of error less than or equal to 2%. So to summarize, because there was a lot of algebraic talk in there, if you're controlling the margin of error and they do not give you a previous p-hat value, you just use 50%, 0.05, and then proceed. Just remember, always round up. That concludes this video, and this is the last series prior to test 3. So when you finish homework 18, test 3 should be waiting for you. So watch out for it in Canvas, and good luck. Contact me if you have any questions.